Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see how to draw the Norton equivalent circuit for a given circuit diagram which is having a one independent voltage source and one dependent current source. As we know that the Norton equivalent circuit is having a current source, that is IN, is in parallel with the resistor RN. This is terminal A and this is terminal B. The resistance value is Rn and current source value is IN. Now we need to find the value of IN and value of Rn for the given circuit diagram to find the Norton equivalent circuit diagram or to draw the Norton equivalent circuit diagram. For this, as a first step 1, we will find the value of IN. Let's say this is step 1. We will find the value of IN. To find the value of IN, we need to do the short circuit the terminals A and B, and we need to find the amount of current flowing through the A and B terminals, that is IN. To find the value of IN, we will apply the KCL here. So this is the junction. In this junction, the incoming current is IX and the one more current is available, that is 2IX, and the outgoing current is IN. So as per KCL, as per Kirchhoff's current law, in this junction IX plus 2IX is equal to IN. Now we need to find the value of IX. So the IX is the amount of current flowing through the 5 ohm resistor. When we are seeing from the terminals A and B, the voltage source, 10 volt voltage source, is directly connected with the 5 ohm resistor. As we see here, the plus terminal, positive terminal of the voltage source is connected with the 5 ohm resistors one end, and another end is directly connected with the negative terminal of the 10 volt source. So the amount of current flowing through the 5 ohm resistor IX is equal to 10 divided by, this is the 10 volt, 10 divided by the current resistance value is 5 ohm. So the IX value is 2 amps. So the 2 ampere amount of current is flowing through the 5 ohm resistor. Now we will apply the value of IX into this above equation. So the IN will become, the value of IN will become 2 plus 2 times of IX, 2 times of 2, so this will become 6 amps. IN is equal to 6 amps. Fine. On next, we have found the value of short circuiting current IN. On next step, we will find the value of RN, that is step 2. In step 2, we will find the value of Rn. Here the voltage source was present, we need to do the short circuit. We did the short circuit. Now one dependent source is present here. As the dependent source is present, we need to inject the known value of voltage source. Assume that the voltage source V0 is equal to 1 volt I am injecting. Now we need to calculate the amount of current I0 which is flowing in the circuit. So from this we can find the value of Rn, that is V0 by I0. In case if I am injecting the known value of current to this circuit, we need to calculate the voltage across terminals A and B. Then we can find the value of Rn by using the same formula. Now as we did the short circuit in this above diagram, the 4 ohm resistor will be short circuited. So remaining will be the dependent current source 2Ix and the 5 ohm resistor is present. When we see this circuit, the positive and negative terminals of the reference voltage is directly connected with the 5 ohm resistor. So the amount of current flowing through the 5 ohm resistor is minus Ix is equal to V. V is what? 1 volt, and the resistance is 5 ohm. So the total current flowing through the 5 ohm resistor is 0.2 amps, or we can say Ix is equal to minus 0.2 amps. Next, we know that the value of Ix is equal to minus 0.2, and the amount of current delivered by the dependent current source is 2Ix. So the 2Ix is equal to minus 2 times of 0.2, which is equal to minus 0.4 amps. So here at this junction the current flow is, this is Ix and this is 2Ix. So the total current is I0 is equal to, as we know that Ix is equal to minus 0.2 and this is 2Ix is equal to minus 0.4. So the total current delivered by this reference voltage source is negative 0.6 amps. Now we will calculate the value of Rn using this formula. So the formula is Rn. We know that the voltage injected value is 1 volt. So we will write 1 volt divided by the current is negative 0.6 amps. So the resistance value, Rn value, is equal to negative 1.6 ohm. So Rn is equal to negative 1.6 ohm. Now we have found the value of Rn and we have found the value of In. Now we will draw the equivalent circuit of Norton. So the value of In is equal to, we know that the value of In is equal to 6 amps and value of Rn is equal to negative 1.6 ohm. If you have any doubt, please write it on the comment box. I will reply. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. Thank you so much.